All right, so let's try something different here. Let's do a present value problem. Now let's look at number 5. So 5 says Cheryl wants to have $2,000 in spending money for a trip to Disney World. And she wants that in 3 years. So what does she have to start with today if it's going to grow at 5% a year in order to grow to $2,000? Okay, so let's do a timeline again. All right, let's do a timeline. Let's say, this is number 5, that Cheryl wants that $2,000 in 3 years. So if it's going to grow at 5% a year, that's the IY, and we're going to use the calculator for this, then she needs to start with what amount? So for 3 years, this will grow. The interest rate, it'll grow at is 5%. At the end, it's going to be worth $2,000. What does she have to put in today in order to get that? Well, the number's going to be negative because that's got to be an outflow for her right now. She has to put that money aside into an account. Well, you can do this with whatever calculator you want. Let's do it with the graphing calculator here. I'm in my solver, right? So I hit apps, number 1 for finance and number 1 for solver. And I say, oh, n is 3. She wants $2,000. Oh, by the way, notice I have my PY and CY set at 1. You want your PY and CY set at 1 when you do these. Okay? And don't mess with those all semester. Just leave those alone. The interest rate, oh, and the payment is at end. That means it's an ordinary annuity. If we flipped it over to begin, we would be doing an annuity due, but I'm not really going to do that with you. Okay, so the interest rate here that she's going to be saving is 5%. There's no payment, so what's the PV? Alpha, enter, 1,727.68 cents negative. So she has to set aside a cash outflow into the account of 1,727.68. Great. That's the answer. If you're using this calculator over here, then let's turn it on. Let's clear second, clear your time value of money, and then just since we're here, and I mentioned it with the other calculator, hit your second and your P/Y. That should be 1. If it's not, set it to 1 and hit enter. Okay. All right. So same problem with this calculator. If you start to pick up some speed with some experience, you hit the 3 and then the N, the 5 and the interest rate. She wants $2,000 in the future. Compute present value. That's where the 1727.68 came from. All right, let's try something with an annuity, and let's also step it up a notch significantly in difficulty for number 9. So number 9 says twins, Jessica and Joshua, are 25 years old. They graduated from college, and they begin working in the family business. Jessica puts in $2,000 a year into her retirement, but she does that for just the first 10 years. So from age 26 to 35, she puts in $2,000 on those years. But then she doesn't add anything more into the account. Her brother Joshua, on the other hand, he doesn't make any retirement contributions for 10 years. He waits until he's 35, then he starts putting in his $2,000 a year, and he does that for 30 years until age 65. If they each make 10% a year on whatever their accounts are worth, then what do they end up with at retirement at age 65? Now, maybe you're already guessing this correctly, but the question here is basically priming you to learn something. The question is effectively really trying to catch you and note that, hey, saving earlier might be even more important than saving a lot of money. Let's do these separately, and let's actually do Joshua first. He's the second twin here, but let's do him first. Got my fiance's wedding planning notebook here. It's the only scratch paper I could find, so I got bedazzled pink everywhere. All right. So let's talk about Joshua first. Well, he's going to do nothing from age 25 times 0 all the way until age 35. He's not going to do anything at time 10. And then he's going to start making contributions every year after that until age 65. Okay. This is time 40 kind of on the timeline. Well, what's he really going to do here? He's going to make 30 contributions. Now, the first one, I'll be frank with you, and this will seem kind of weird at first. The first $2,000 contribution is going to come right here. I put minus 2,000 because it's a cash outflow for him. He has to set the money aside into the account. And then he's going to do that every period all the way through time 40. And at time 40, he has one final minus 2,000. If you count those up, there's 30 of them. You start at the end of the first period because he starts with his policy here, time 11, 12, 13, all the way through time 40. That's $2,000. All right. He has 30 of those payments. The interest rate is 10%. The payment amount that he's setting aside is so negative $2,000. What's he going to have at retirement here at age 65? The future value here, well, let's use this calculator. He's got 30 payments, gaining 10%. The payments, there's no present value in this problem. This is an annuity. All the payments are $2,000 each. They're equal in amount. That's why you can use the payment button. They're $2,000. That means he'll have $328,988 in the account at the end. Sounds like a lot of money, and it was a lot of work, and he set that aside. How much did he actually contribute? Because that's part of the question here. If you read it, it asks, well, how much did they each contribute? Well, Joshua contributes $2,000 a year 30 times, or $60,000. Let's look at the same kind of thing for Jessica. Hers is a little more complicated. So we're going to do an annuity and then a twist on it here. She starts saving her $2,000 a period at the end of the first year. So on her 26th birthday, she's going to make her first payment. And then she's going to make 10 of these until age 35. Then she does nothing else. No more payments after that. And we're going to go all the way to time 40, and we're curious what she's going to have then. That's the big question. How do they compare? All right, well, this annuity in her case only covers 10 periods, and then it stops. So to do this problem, what we're going to do is say, oh, she's going to make 10 payments. The interest rate's 10%. The payment amount is, again, negative $2,000. What does this grow to in 10 years? In this case, the future value is at time 10 because she made these 10 payments. What's it worth? All right, so I'm going to go, let's use the other calculator. Try to keep mixing it up here. So I'm going to hit cancel. I'm going to hit second, clear my time value of money. And now I'm going to say 10 interest rate, $2,000 negative, payment grows to $31,874.85. So $31,874.75. That's the value of her account at this point. But it's going to grow for 30 more years at 10% a year. But the whole key is there's no more payments. There's no more payments of $2,000. So you're done with the annuity portion of this. Now you've got the lump sum value that she has here. Well, that's at time 10, though, 10 years from now. What's it going to be worth 40 years from now? So you kind of have to, this is a little bit different, but you got to get used to thinking about the fact that PV just means earlier on the timeline and FV means later. So this amount, this $31,874, that's a present value when I do my next piece of the calculation. And she's going to take that aside from the account. She's going to set it aside again, so we'll put a negative sign on it. And it's a lump sum. It's not a payment amount. It's not an annuity, which reoccurs. She's going to make those payments. Excuse me, I said it exactly wrong. She's going to take that amount. She's going to have it grow, but it's a PV. It's a lump sum. It's not a payment amount. It's just a one-time lump sum amount. It's going to grow for 30 years from age 35 to 65. or time 10 to time 40. It's going to grow at 10% a year. What's the future value? All right. Hit the second key, clear my time value of money. I'm going to say, 30 years at 10% interest per year, 31,874 negative present value, compute future value, 556,182.25. So 556,182.25. This is supposed to be a big eureka moment for you where you learn something big, because look, how much money did she put aside? She put aside $2,000 a year times 10 years, or $20,000. Her twin brother up here put aside $60,000. She put in 1/3 as much, but at the end of the period for retirement, she's got a lot more money. That goes back to how I introduced this. The whole idea here is it's not even as important sometimes how much you set aside as how early you set it aside. Joshua set aside a lot more money, but he waited 10 years, and so at the end the final amount was less. Jessica started right away, and so while she only did 10 years of these, the extra time here made a big difference in the bottom line. That's some practice on annuities and a little bit of life lesson, I guess, about the importance of being prudent and saving, especially early. Okay, you got more examples of these to try. Check your solutions. We're going to do one more here on the next part where we talk about monthly compounding as opposed to annual.